Okay, for today's lesson, you are going to become mathematicians. So, mathematicians work hard to create formulas to make math easier, right? To make our math classes easier. And today we are going to recreate this process, but to create a formula to find the sum of a geometric sequence. The process that we're going to be doing today is called deriving the formula. So, it's where we start with something that we know and we manipulate it in order to get a formula that will always work. Now, typically the manipulations that we have to do sometimes can be kind of funky. They don't really make sense. We don't really know why exactly this works. But that's what mathematicians do. They try one thing and it fails, and so they try something else and they try something else, and they get really creative to find a way to create formulas that just make math easier for everyone else. So this is a known formula that we have today, and we're going to recreate this process to derive the formula for the sum of a geometric sequence. For this first one, we're going to see if we can derive the formula for the sum of the first 5 terms of any geometric sequence. So we're going to be dealing with only variables for example 1. It'll be helpful for us to remember the formula for the nth term of the sequence, and that is this formula right here. As I go through these steps, I'm going to do the steps, and then sometimes I'm going to just ask you to pause and watch and listen to what I'm saying. I'm going to put some work on my paper. You're free to copy it down on the side of your paper, but it's just going to show you why we do what we do. What I really want you to get down is the steps and the format for how we derive, because you will be asked to derive these problems yourself. All right, step 1, as we derive the sum, is going to be to rewrite every term in terms of this formula for the nth term. So this nth term can be used to find any term we want in a series. So if I wanted to find the first term, a sub 1, I would plug in 1 for n. I get a sub 1 times r to the 1 minus 1 power. Well, 1 minus 1, we know that that is 0. So this is a sub 1 times r to the 0 power. That is a sub 1. So that's what I'm going to read. That's what I'm going to do. I'm going to rewrite all of these in terms of that formula. So we have our new s sub 5. And for the first term, it's going to be a sub 1 times r to the 0 power. Plus, okay, for the second term, for term 2, a sub 2 is going to be a sub 1 times r to the 2 minus 1. Well, we know 2 minus 1 is just 1. So this is going to be a sub 1 times r to the first power. For the third term, that's going to be a sub 3 equals a 1 times r to the 3 minus 1 power, or to the second power. So a 1 times r squared. All right, we're going to do the fourth term. A 4 is going to be a1 times r to the 4 minus 1. So a1 times r cubed. And the last term, the fifth term, is a1 times r to the 5 minus 1, or a1 times r to the 4th power. Okay. This next part here is where I'm going to ask you to pause. You don't have to copy down everything I do. I'm going to show you what we're going to do and the math behind it. So, step 2 is going to be to take the equation we have and multiply it by r, by that common ratio. So I'm going to multiply this entire equation by r. So I'm essentially distributing this r to every term. We've got a bunch of terms in here. I'm going to multiply each one by r. So for this first one here, we've got r times s sub 5 equals. The second one, I'm multiplying a sub 1 times r to the 0 power times r. Well, let's think about this for a second. What I'm going to get is a sub 1 times r to the 0 power times another r. Thinking about exponent rules and the exponentials we've just learned about, is there any way that I could simplify this term? I could condense some things down into a simplified version. If you notice, we have two bases that are the same. We have r to the 0 power times r to the first power, right? If there's not a power, we know it's 1. Could I condense those down into one base of r? If two terms or two pieces are being multiplied together, I can condense them into one by adding their exponents. So this is the same as, bring that a sub 1 over, r to the 0 plus 1 power, and 0 plus 1 is 1. So when I multiply by r, I'm really just increasing the exponent on r by 1. So this becomes a sub 1 times r to the first. All right, when I multiply the next term times r, it's really going to increase the exponent by 1. So I get a sub 1 times r squared. Again, when I multiply by r, I'm really adding 1 to the exponent of r. So a sub 1 times r cubed. All right, let me show you the math one more time, just in case you didn't catch it the first time I did it. For this next term, when I multiply by r, I have a sub 1 times r cubed times another r. I want to condense these two into one base of r. That's going to be r to the 3 plus 1 power, or r to the 4th. So this next term is going to be a1 times r to the 4th, because I'm essentially adding 1. And then we get to our last term. Again, I'm adding 1 because I multiply by r, a1 times r to the 5th. Okay, so we've multiplied everything by 5. I'm going to bring this back over to the problem itself, so you are going to have to copy this down now that we have a simplified equation. So if you need to pause the video as you copy that down, that's fine. The next step is going to be to subtract these two equations. So if you remember back to Algebra 1, you used to have to solve using a process called elimination. So using this process, you have two equations, and with these two equations, you are going to subtract one or add one to the other in order to condense them into one equation. So you multiply the left sides of, or you add the left sides of the equation, you add the right sides of the equation, and you get one new combined equation. And that's what we're going to do here, but we are going to be subtracting. Now when we subtract, remember we have a lot of terms, we have to distribute that subtraction to every term. So we're subtracting this term, we're subtracting, 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 and I'm going to condense it into one. So on the left side of the equal sign, I have s sub 5 minus r times s5. Now on the right side of the equal sign, I'm going to have, there's a lot of terms over here, and if I can, let's see if we could simplify anything before we just start rewriting them all. So I have a sub 1 times r to the 0. We have a1 times r to the first. Notice that I also have a negative a1 times r to the first. So a1 r to the first minus a1 r to the first, those two terms would cancel each other out, right? All right, let's see if we can find any other common terms between these two lines. The next term is a1r squared. Well, I also have a negative a1r squared. Same term, one positive, one negative, those two will cancel out. I have a1r cubed, and I see a negative a1r cubed. Those two will cancel out. I've got a1r to the 4th and a negative a1r to the 4th. Those two will cancel out. And I'm left with this last term and this first term. So a lot of things that we got away with not writing, I've got a1r to the 0 power minus a1 times r to the 5th. Okay, the next step that we are going to do is factor out a GCF from both sides. So on the left side, S5 minus RS5, I'm going to factor out the S sub 5. Just like it's a GCF. When I divide that away, I'm left with 1 minus R equals, on the right side, I notice they both have the A sub 1 term. So A sub 1. And I'm left with R to the 0 minus R to the 5th. Now, those both have the base of R, but because they're being subtracted, I cannot condense them at all. But there is a little bit that we can simplify. Do you see it? What is any number, variable, anything raised to the 0 power? It is always equal to 1. All right, now our goal is to derive a formula for the sum S sub 5. So we want to get S sub 5 alone. All right, the next step is going to be to divide by 1 minus R, right? Because that is what's keeping S sub 5 from being alone. It'll cancel on this side and move to the other. So I'm left with S sub 5 equals A1 times 1, remember it simplified, minus R to the 5th over 1 minus R. Nothing else here will reduce, and we have successfully derived the formula. Now, do any of these pieces in the formula look familiar? Like, what pieces are we left with? Well, we've got S sub 5. We have A1, which remember that A1 is that first term. We've got R in here, so we have that common ratio. We also have a 5. Anybody see where the 5 comes from? That comes from the number of terms we want to sum. All right, in the next video, I'm going to do example 2, which has numbers.